Hello everyone, welcome back to my channel. In this video, we are discussing the next part of our data science question paper where we are going to discuss about section B, which is focused on dissimilarity, distance measurement techniques and similarity rankings. So we will go through four important as well as impactful theoretical questions where first question is how different attributes type affect dissimilarity, how to calculate multiple distance metrics, how to approximate median efficiency and how to compute similarity ranking in multidimensional complaint data. So here, briefly outline how to compute dissimilarity between complaint profile described by A. Nominal attribute, B. Asymmetric binary attribute, C. Numeric attributes and D. Term frequency vectors. So moving ahead with this question, basically A. Nominal attribute are categorical variable which can take more than two possible values. The dissimilarity between two objects I and j can be computed using mismatches. So where d of I comma j equal to p minus m upon p, where m is the matches and p is the total number of variables. So we can compute using this formula. Next is asymmetric binary attribute. So for this, binary attributes are 0 and 1 values, but in asymmetric binary, the 1 value carries more importance than 0. So in this case, negative matches are ignored and only positive occurrence are matters. So this formula is used, d of ij equal to r plus s upon q plus r plus s. This treats presence more seriously than absence. Next is numeric attribute. So use Euclidean distance, Manhattan distance, Supremum distance. Euclidean distance is defined as, here is the formula written here on the screen. So here is Manhattan or city block distance. This is the formula for city block. And Supremum distance, the formula is here. Term frequency vector to measure the distance between the complex object represented by vectors. It is often easier to abandon traditional metric distance computation and introduce a non-metric similarity function. So basically, numeric variables allows distance computations using these three techniques. Euclidean distance compares square differences, Manhattan distance compares absolute differences, and Chebyshev takes the maximum difference across the dimension. Next is term frequency vector. So in the last technique, term frequency vector, where we deal with the text objects can be represented using term frequency vectors. So similarity is computed using cosine similarity. Here we use cosine similarity. So this measures how close two text documents are based on directions and not magnitudes. That completes the question number 1 of section B. Now let's move ahead with the question number 2. Let tuple cases are 22, 1, 42, 10 and 22, 0, 36, 8 representing incident duration minutes and witness present in 0/1 exhibits evidence items count count compute the following distances among. We have to compute Euclidean Manhattan Minkowski distance with h3 and last one is Supremum, which is also called Chebyshev distance. So for this we have given two tuples. Euclidean distance uses the square root of the square differences. So we have the formula and where we have to put the equations and we have to put the values in the equation and we got the result as 6.7082. So Manhattan uses the sum of absolute differences in second. Here we calculate for Manhattan, answer is 11. So Minkowski generalizes both of the above Supremum measures maximum coordinate differences. Minkowski, here is the formula and we calculate the Minkowski as 6.1534. Last, the Supremum distance between the two objects. The Supremum distance is computed using equation 2.8. Therefore, we have a Supremum distance of 6. Here is the formula for Supremum distance, 2.8. So, on using this formula, we get the answer as 6. So, Supremum measures maximum coordinate differences. So, you can read the numerical values exactly from your solved answer in the textbook and I will provide you this answer sheet and solve from here. So moving ahead with the next question. Question number 3. The median evidence impact score is often a robust indicator for a triage. routing to fast-track scrutiny versus detailed legal vetting for massive complaint dataset, propose median approximation method like GK quantile summarizes, T digest, reservoir sampling, analyze time space complexity, and suggest heuristic to balance accuracy versus efficiency. So for this question, basically, this question discusses why the median is very important in statistics and asks for approximation methods when data becomes very large. So this question can be dealt with either theoretically or empirically, but doing some experiments to get the result is perhaps more interesting. Median is robust where less sensitive to extreme values and therefore useful for detecting central evidence scores in complaint processing. So for use dataset, computing exact median becomes expensive. So we use approximation methods like quantile approximation, T-digest, reservoir sampling, and hierarchical division of the dataset into smaller regions. So the idea is to compromise slightly on the exactness but drastically reduce computation time and space. So these things are only written here, and this is the practical approach for this question. So here we complete this question. Like we can confine the median to the smaller areas with globally partitioning all data into shorter intervals, which is expensive. The cost is proportional to the number of intervals. So here the question is completed. Now moving ahead with the last question of this section. Basically, the last question of this section is question number 4. A sample dataset with 2 numeric features per complaint. Responsiveness of accursed, support gained due to infrastructure misuse, scale from NLP extraction. So here is the dataset we have given. 5 complaints are there and 2 features are there. Given a new complaint query, we have given a new complaint and rank existing complaints by similarity using Euclidean Manhattan, Supremum, and Cosine similarity. We have to calculate rank that normalizes each complaint vector to unit length and recompute Euclidean distance. So for this question, basically for this question, we have Euclidean distance formula. We put the values and we get the answer. So we are given a data table representing objects with 2 numerical attributes. We are asked to consider each object as a 2D point and compute distance from query X, which is 1.4, 1.6 using Euclidean Manhattan, Supremum, and Cosine similarity. And second, we have to normalize the data to unit length and recompute Euclidean distance again. So the output generates ranking of the objects depending on which similarity measure is used. Different measure produces different ranking because each metric captures the different aspects of the closeness. So for this, we have Euclidean distance, Manhattan, Supremum, and cosine. And we already discussed their formulas, put the value, and we get the answer like this. After normalization, the normalized query is 0.65850, 0.75258. The normalized data set is given by the following two things. Here is the table. And we compute the Euclidean distances before yield. We got this table. So which resulted in the final ranking of the transform data points x1, x2, x3, x1, x3, x4, x2, and x5. So basically, in this section, we understood how attribute type affect dissimilarity measures, how multiple mathematical distances are computed, why median approximation becomes necessary for large-scale dataset, and how similarity ranking changes depending on the distance matrix and normalization. These concepts are extremely important for machine learning, data mining, secure complaint routing, whereas for legal analytics. So thank you for watching this detailed discussion, section B. If this helpful, please make sure to like the video. Also, don't forget to subscribe to the channel, and let's discuss about part C in the next video. Thank you.